Hello, dear students. Today we learn the slope and deflection at free end for a cantilever beam subjected to W at the free end. Now this is the cantilever beam is subjected to W at the free end. Our aim is to find the slope and deflection at the free end. So by method is by moment area method. So for the moment area method, we will draw the deflected shape here. Suppose this is the deflected shape. Also draw the bend moment diagram for this beam. So we know here is BMD is like this, that we know, and that moment is hogging, that is a minus. Okay, so W into L is the bending moment, and here divided by the EI, so this diagram becomes the M by EI diagram. So now we know the here in the case of fixed end, the slope at A is 0. Now our aim is to find the slope and deflection at the free end. Suppose we want the slope at the B, so draw the tangent at here. So now this becomes our theta B. So the tangent drawn at A and tangent drawn at this is the B dash, suppose. So tangent drawn at B dash and tangent drawn at A. So this is our, so this is the theta B. So we know that change in slope, the first theorem, change in slope between the points, that is equal to area of M by EI diagram between these 2 points. So change in slope is what? Our is theta B, and again we have drawn the tangent from A. This is the passing like this here, the same point. So theta A, that is equal to A by EI. But we know that theta at A, because of fixity, is theta A is 0. Theta A is 0 due to the fixed end. At the fixed end, the slope is 0. So what here? So theta B is equal to A by EI. But what here? What? Between theta, area between which? B and A. So area between this B and A. So that is equal to here. Here is how much? Because of hogging, minus 1/2 base into height, this WL upon EI. So here theta B becomes minus WL square divided by 2EI, and this minus indicates the slope is the clockwise. From here this slope is the clockwise, so that is why is minus. Now we got here the slope. Now our aim is to find the next is the deflection. For the deflection, what here? This is delta. Also, if you draw the tangent from the A and vertical line from this elastic curve, this, suppose, so this height is also called as TBA. This is also called as a TBA. So we can say that this TBA is also is equal to delta is equal to now AX bar upon EI. TBA, B means B, draw the vertical line at B and draw the tangent at A. So draw the vertical line at here B and draw a tangent at A. So the moment of the area between these 2 points with respect to the B, means with respect to the, this where we draw the vertical line, this is our reference, and this becomes the X bar. This becomes the X bar. Here this TBA and delta is the same. That is why we got the directly delta, otherwise not. So here we can say that this TBA or is equal to delta is equal to BA, means what? Area between this minus, because of hogging, 1/2 base into height into, from here the central distance, that is the 2/3 of the L. So L, this 2 gets cancel. So this delta is equal to minus WL cube upon 3. This minus negative sign indicate this TBA is above the elastic curve. This TBA is above the elastic curve, that is why this sign is the minus. So we got the value of the slope here, and this deflection. Thank you.